So I'll go into power Dorito pickup.h, include a timer. Oh, no, actually animated sprite already has a timer in it, so I don't even need to do that. Let's just create a timer, and initialize it in our constructor. So timer, and we will give it a k lifetime variable, which we'll create, and we want to start it active, so give that a true. So let's create some timer constants. Let's do a const units of milliseconds. K lifetime equals 8 seconds, or 8,000 milliseconds. Let's give ourselves a k flash time, which will just be 7 seconds. And then finally, let's give ourselves a period. So flash period, and this will be 50 milliseconds. Now we can go into update and return timer.active instead of just true. And then we can go into draw, and we will want to draw if our timer.current time is less than our k flash time, or we want to do our little trick, which is to say if timer.current time divided by k flash period, divided by k flash period modulo 2 equals 0. And that'll give us a nice flash effect at the end. And that should do it for our timer, so I'll build and run this, make sure this is working and that it disappears after a set amount of time. There it goes. Perfect. Alright, it's finally time to start giving our Doritos some life. So I'll go into powerdoritos.h, and we're going to need to include map collidable. We'll want to inherit from it privately again. We don't need to expose update x or update y to anyone, so private map collidable. We'll need to implement two private methods, which were void on collision, which takes in a side type, side, and a bool is in direction of delta, so is delta direction. And we'll also need to implement on delta, which only takes in a side type. And this one, we aren't going to do anything with it, so I'll just give it an empty implementation. I'll copy and paste the function declaration into our CC file so I can implement it here, power Dorito pickup. Let's call this, no, that's good. So let's see, what were we going to do? So if it collides with the top, so if, doesn't matter if it's the delta direction, but if side equals top side, then we want to set our velocity y to be equal to 0. So kinematics y dot velocity equals 0. Otherwise, if it's the bottom side, we want to give ourselves a bounce velocity. So I'll just call this k bounce velocity. Let's go up to the top and define it. So const units of velocity. Actually, I call it k bounce speed. How about that? And then make it just positive k bounce speed. And this will be 0.225 f. So let's go back down here and call this negative k bounce speed. Otherwise, we just want to, we hit the left side or the right side, so we just want to reverse directions in the x. So kinematics x dot velocity equals negative kinematics x dot velocity. So now we have implemented our map collidable interface, but we also need to be able to call update x and update y. So that requires an accelerator for the x, an accelerator for the y, as well as a simple or a collision rectangle. So let's include simple collision rectangle because that's the type we're going to be using. Let's also include our accelerators. So let's start with the accelerators. Those are easy. Const. This, we're just going to need K gravity, which already exists, but then we'll also need a friction accelerator. So friction accelerator, K friction. We'll initialize it with a value of, after experimentation, I came up with 0.402. So now we have K friction. We also need to create a list of simple collision rectangles, or an array, I mean, of simple collision rectangles, because we have one for each size. So let's call it const collision, simple collision rectangle, K collision rectangles. It's going to be an array, and let us define it. So what did I say? It's 16, 24, and 32 were our sizes, so let's create it knowing that. So given simple collision rectangle, all it takes is a single rectangle. It will be 8 units, 8 units. Its width and height are 16. The second one, width and height are 24. And to be centered, we need to change these 8s to be 4. And then finally, we are all the way flush at 0, 0, and our width and height are 32 by 32. And those are our collision rectangles. So now we can call update x and update y for our map collidable. So let's do it in the reverse order. Update y first. So map collidable, update y, giving it our collision rectangle, which is K collision rectangles sub size. Our accelerator for the y direction, which is going to be gravity. So constant accelerator K gravity. We want to pass in our kinematics x, our kinematics y, our elapsed time, and our map. And oh my gosh, how easy was that? Let's do x now. That's going to be easy as well. So x, same rectangle. The only difference is the accelerator we're going to use is our friction accelerator, which we defined in K friction. And that is it. We have just implemented motion for our power Dorito pickup. Let's also do our collision rectangle because that was so easy and we have some time to spare. In this, we are going to use our simple collision rectangle's bounding box because it's already there, might as well use it. So we just need to add in our position to it. So kinematics x dot position plus our K collision rectangles sub size dot bounding box dot left. Same thing for y, except it's y and top. And then we also need to use our bounding box's width and height. And that is our collision rectangle. And I think that concludes the episode. Let's build it and see it, except I'm getting a warning. So collision, yeah. Just put a little F here so it knows it's a float. So let's build, let's run. Look at it go. I mean, it goes off the screen and that's not good. Maybe I should put some walls up. There is our Dorito. I don't seem to be able to pick it up, which is not what we want. I mean, we do want to be able to pick it up, so let me look and see. This all looks right, so maybe we're not calling it. Let me check. Oh, I bet I didn't call it. Yeah, so we also need to call pickups.handle collisions. We can do that after, how about right before we collide with enemies, just to be more fair to the player. So let's do player. Nope, let's do pickups. I mean, pickups dot handle collision with our player. And now we should be colliding. Let's see. Yes, I collected some experience. Looks great. Okay, so that's it for this episode. Yeah, I think my favorite part about this episode has been just how fast and easy it was to implement motion. It's literally just these two lines. I mean, I guess four but they're just two function calls, update y and update x, and we just define our k friction, which was, again, super easy. You just give it a constant. And so I think we're going to see that this is really going to pay off in the long run, that kind of abstraction. But yeah, this has been fun. And we now have a Dorito. Next episode, we'll work on making it look good. Or not making it look good, sorry. Making it so that the player will get his little +1 experience, and it'll show up in the upper left, just kind of hooking everything together. So that's it for this episode. Thanks for watching, guys, and happy developing.